now it's showing you a picture. Let's see if I can draw it halfway decent. And then what's in this chamber?
2.1 liters of N2.
Okay.
And then you have 3.7 atmosphere.
Okay.
And then the other one, you have 3.3 liters of CO2.
Okay.
And 9.2 atmosphere.
I shouldn't have drawn them so big. Now I have no boardroom. Shrink them down. Now they'll just be lopsided. Okay. And then you said the valve in between is open, so they can exchange.
So they're both exchanging back and forth. So what's the final pressure?
Okay. Because you see right off the bat, like this is only 3.7 atmospheres, this is 9.2.
If it opens, it's going to flow.
Yeah.
3.7.
Yeah, they're going to balance out and eventually end up equal, right? Okay. So our number of moles isn't changing. Our temperature's not changing.
Our volume's going to stay the same, but the pressure's going to change. Because volume will, when it opens, the volume's always going to be 5.4.
Total volume?
Yeah.
Yeah.
Total volume. So would that be V1 and V2? No, that would be V2. If we were solving for the first one. If we were solving for N2.
If we're solving for
Our
N2.
P1 would be 3.7.
Right. So this is for N2.
Yeah,
So P1,
it's 3.7.
okay.
And V1 is 2.1. And now the V2 is going to be 5.4. But we don't know what P2 will be. So that's what we have to solve for.
Okay.
And so if you plug that in, you go 3.7 times 2.1 and divide that. Yeah, equals, and then divide that by 5.4 would give you your P2.
Right. Our liters would cancel. We'd be left in atmospheres. What does that equal?
Oh, 1.439.
Okay, so that's for X for N2, right?
Yeah.
So let me make a side note over here. So P2 equals 1.439. I don't know, that might be too many sig figs, but it's okay for now. Okay.
For the CO2, your initial pressure is 9.2. And the volume is 3.3.
Okay. We don't know P2, right?
No. Our V2 is going to be 5.4.
Okay. So then we'll do the same exact thing. Plug in 9.2 ATM times 3.3 liters. That's going to equal X, right?
Yeah.
And then divided by V2, 5.4 liters. Liters cancels. X equals
5.6. Find it the same one it's at.
okay, so for CO2, 5.6. Okay.
And then do you just
Are these the numbers he gave you in class?
Yeah.
That's like the final answer, he said?
Yeah. No. No, I said it was 1.44 and then 5.62. So he just took it to 2 decimal points.
Okay. One of the first things I like to...
That's what he gave us, but then he said that the answer is 7.04. That comes out to be 7.06.
Well, when you added them or something?
5.6.
Are you saying when you added them?
Yeah.
Oh.
Maybe he just did 5.6 instead of the...
You said he only went to 2 sig figs, right?
Yeah.
So this would become...
That one was 1.44.
Okay.
But he kept that. But then the other ones you only did 5.6 on. That would give you 7.04.
Okay. And first of all, I'd like to say, does it make sense? So you started with 2 liters of N2 at this pressure. All of a sudden, there's more volume. So you know if there's more volume, pressure is going to go down, right? Because volume and pressure are inversely related. So that makes sense, it went down. Okay, you look at the CO2. 3.3 liters at 9.2 atmospheres. You give it more volume, it's lower. Seems reasonable. I mean, like that's just really basics, but it matches at least the trend.
Yeah.
And then you know that total pressure, right? So P total equals, that's mole fraction, sorry, equals, partial pressure of A plus partial pressure of B. Well, A and B are just partial pressure of N2, partial pressure of CO2, right? So that's why you just added them.
Okay.
So you want the total pressure in the container. You have to say, and he rounded them, ATM plus 5.6 ATM. I'm writing crooked, but the total pressure equals 7.4, right?
Yeah. 7.04.
Oh, 7.04 ATM. Does that make sense? Does it make sense why you added them at the end?
That makes more sense now.
Because have you already talked about, like, if you wanted, maybe he said the total pressure in this container is this. What's the partial pressure of N2? This is how many moles you've got. Like, does it make sense? Have you guys gone over that yet?
Not yet.
Okay. Okay, you will. But you have gone over this.
Mm.
Okay. It makes sense,
That's what
though.
we went over right at the end of class was this.
Oh, okay.
So,
Does it make sense why? I mean, you say total pressure.
yeah.
Well, if you have 2 atmospheres coming from one gas, 2 from another gas, total pressure is going to be
Yeah.
4. It's going to be both of them.
However much is added in.
Right.